get started. I would like to introduce KYZEN's own Chuck Sexton.
Thank you, Chelsea, and thank you everyone for joining my presentation today. This presentation is on multiple stage cleaning systems, parts cleaning washers, where you have different chemistries in different stages for washing, rinsing, application of an RP, rust preventative. And the main question is that we're trying to answer here is, can you use the same chemistry in all the different stages, or at least some of the different stages? What I've drawn here is a sort of a universal flow diagram for representing many different types of parts cleaning systems. This could be tank-to-tank immersion, ultrasonics, spray under immersion. This could be a conveyor spray washer, a rotary drum system, or a single chamber rotating basket washer where you're bringing in through different cycles of wash in the rinse and the corrosion inhibitor chemistry. For the sake of this presentation, I will focus on certainly what we see the most of in manufacturing, and that is a relatively simple three-stage wash, rinse, dry washer. In this system, we would normally have a cleaner in stage one. The most common cleaning chemistries are alkaline cleaners, and then we would have a RP or corrosion inhibitor in the rinse. Here's the problem. Once the RP in stage two is contaminated with the cleaning chemistry from stage one through carryover or drag out, we can no longer measure the RP concentration in stage two by conventional methods. And by conventional methods, I mean these three: conductivity, refractive index, and titration are certainly by far the most common methods that we use. They're nice, they're simple. The test could be conducted at the washer itself. You don't need usually a sophisticated analytical chemical lab. And these three methods lend themselves nicely to producing control charts. Here's one I have shown for conductivity, where you see conductivity on the left as millisiemens, and the bottom scale is percent concentration of the particular chemistry, and the line relates the two different numbers to each other. Similar charts can be produced for titration and refractive index. They actually look a lot alike. The numbers relate differently, but I actually like to have one of these charts laminated and hanging at a machine. Probably, I would say, more than 80% of the cleaning systems that we see using alkaline cleaning chemistries can be very well measured and controlled by conductivity. Here's a system that's an automated chemical addition system that measures the conductivity with the conductivity meter that you see on the left side, and it sends a signal to a metering pump based on the conductivity or concentration that's actually being measured in real time, and then the chemical addition pump adds the chemistry at the right amount. That's all I'm going to say about methods for measuring and controlling aqueous bath concentration in these wash systems. If you'd like more information, our regional manager, Ethan Mueller, did a really nice, much more in-depth presentation that you can find on the KYZEN Tech to Tech website. He did this presentation on October 15th of last year. So we and others have fought the two chemistry intermixing problem for years. And we've come up with a couple of solutions. Solution number one is development of a combination cleaner RP product that's designed for steel. The pH is a bit too high for aluminum. That can do a couple things. It can remove very difficult contaminants like chlorinated paraffinic oils and burned on carbon. And the second key criteria or requirement is that these products provide greater than 90-day protection for mild and cast steel, which I'll refer to as long-term protection, in a non-air conditioned warehouse during the summer months, whether it's Malaysia or Michigan. It's very hot and humid in both places in July. The solution number two grew from number one, if you will. Same criteria for the types of contaminants that you're able to remove, very difficult contaminants. But we wanted an aluminum safe product that would also provide long-term protection for aluminum, brass, copper, and other copper alloys. The reason this solution, or solution number 2, evolved is because many companies today want to clean both steel and aluminum parts in the same washer, sometimes at the same time, and they don't want to change out the chemistry to a product that's aluminum safe. And also, many assemblies today consist of both aluminum and steel. So I've got a couple slides here with some photos. This first slide represents applications for solution number 1, if you will, designed for steel. The parts on the top left are SAE 1010 carbon steel. These are clutch plates. Major OEM automotive manufacturer has this product, one of these Solution 1 products, approved as an RP. I'm showing the bottom left picture because these types of products have really found a home in sintered metal or powdered metal parts. And these types of metals are an exceptional, not problem, but challenge for corrosion protection. This slide shows parts that are applicable for the Solution 2 or the aluminum safe product combinations, where you see a variety of different metals on the top left. And these other 3 photos show assemblies or parts which consist of a combination of steel. I think on the bottom left we have a cast steel and also cast aluminum. So we need chemistries which are compatible with all these metals and which provide long-term protection for these metals. One of the really nice things about moving to one of these new cleaner RP combination products is you can use a humidity chamber where you can do accelerated corrosion testing to develop data to prove to your company and to your customers that making a move to one of these new products is a good move and you won't have corrosion problems. Here, we actually did this for an automotive company. Now, these are the clutch plates, excuse me, that I mentioned on a couple slides back. And in this case, we use the customer's specs for the humidity chamber of 100 degrees Fahrenheit, 98% humidity for 30 days and no rust. And if you pass this test, you can make parts in China and put them on a ship and send them to the US without a corrosion problem. So these products are all oil splitting products versus emulsifying. And many of you, I'm sure, know the difference. With the oil splitting products, we can remove the oil from the parts and then separate it to the surface, where it can then be removed in a coalescer. The advantage of the splitting products is your bath life is 4 to 6 times as long as what you get with the emulsifying products, and the parts come out cleaner because the bath doesn't build up as much oil concentration. So in summary, the benefits of these combination cleaner RP chemical products are probably first and foremost accurate concentration measurement regardless of cross-contamination between stages. You can use the same methods, the same charts, and the same control system throughout. Excellent long-term protection for steel, aluminum, brass, and other copper alloys. Simplified process operation, and effective removal of very difficult contaminants such as burned-on carbon, chlorinated paraffinic oils, and other manufacturing soils. And that's it for my presentation. I'll turn it back to Chelsea. Thank you.
Thank you, Chuck. If you would like to discuss this topic further, please contact your local KYZEN regional manager or send an email to tech@kaizen.com, and we will have one of our cleaning experts schedule a follow-up with you as soon as possible. Again, we thank you all for joining us today, and we hope to see you again soon. Stay safe, stay healthy, and have a great day.